guys, we have discussed various kind of gates, right? So among those, the gates are like, it can be a NAND gate or it can be a NOR gate. These two are a kind of universal gates, right? So in addition to these universal gates, any other gates are there? One is AND gate, OR gate, XOR gate, XNOR gate, and so on. And similarly, any kind of ICs we have seen, like they can be any kind of multiplexers, demultiplexers, yes or no, decoders, encoders, right? So basically NAND gate means is something like a principles what you have seen. So NAND gate means what? When both inputs are low, your output is going to be high. In all the remaining cases, output is going to be 0. Am I right? Yes. That is the theoretically what we have seen. But in the reality, how we are going to implement? Right? So basically, the industries provided all these kind of gates in the form of various kind of circuits. We can call them as ICs, integrated circuits. Integrated circuits. Okay, so we can generally call it as simply as ICs, right? So for NAND gate, what is the IC we are going to use? Any idea? 7400. For NOR gate, 7402. For AND gate, 7408. For OR gate, 7432. For XOR gate, 7486. Similarly, NOT gate is there. For NOT gate, 7404. So like this, we have various kind of gates are there. For all those gates, they have implemented with various kind of circuits, right? So those circuits we are going to simply use, and if you are going to properly connect it, they will work as like as NAND gate, or they will work as like as according to the given circuit what you have used, right? Similarly, if you are going to take the decoders or multiplexers or demultiplexers or whatever the encoders, this internally contains what? Again, various kind of logic gates. Basically, if you want to get these features, you have to make it implement from the scratch with the help of all kind of gates, NAND gates or NOR gates, or a combination of all basic gates, right? So instead of that, they have given already various kind of ICs also. For all these also various kind of ICs given, right? Among those, if you take decoder, the IC name is 74X1382. 74X1381 is a kind of an IC which is meant for to define the decoder. Similarly, for encoder, there is a kind of IC called 74X148. Is an IC which is already given by the developers. If you want to implement this particular feature of encoder, we can simply use that IC and we can able to get our requirements. Like for example, we have seen a concept called conversion of octal to binary. Conversion of octal to binary using the concept of decoders. We have seen or not? Right? So using encoders, not the decoders. Using encoders, right? So what does the meaning of this one? If I am going to give 8 inputs, I need to produce 3 outputs, right? For that, we have drawn some kind of truth table and we have constructed some circuit diagram, and then it is going to work as per our requirement. The same thing we can able to do by simply taking one kind of 8x3 decoder. 8x3 decoder. The decoder name is 74X148 decoder, which is of size, sorry, it should be encoder. Again, I am getting decoder. 8x3 encoder. 8x3 encoder, right? So means here how many inputs are there? 8 inputs. 8 inputs. How they implemented is, they implemented like this. What is the meaning of this one? bubbles, right? So if I am going to put bubbles, I can call 0, 1, 2, 3, 4, 5, 6 and 7. 8 inputs I have passed. As it is 8 by 3 encoder, 8 inputs I have passed, and all the inputs are of type active low. They implement it in such a way that they are all active low, and 3 outputs are there. Those are also again active low. Active low means this will be A, B, C, and assume that this is a MSB bit. So these are also outputs, 3 outputs, and all are of type active low. Active low. Similarly, if you take for any kind of circuit, enabler will be there. Enabler will be there. So this will be an enable, which is also kind of active low. And also not only about these pins, we are going to have various kind of other pins are there. One is GS pin is there, another one is EVO pin is there. GS means group selection. Group selection. EVO means enable output. Right guys, as part of the theoretical concept, what we did, we have simply studied about like it's a kind of 8 by 3 encoder, which is meant for like it is going to take 8 inputs and going to produce 3 outputs. But coming to the implementation, again it is going to be completely different. Different means what? It may be used for various kind of other things. Right? It is not meant for only for the purpose of converting octal to binary. They need to use it for various kind of other things also. In such a way that they have to implement. That's the reason they are going to take various kind of other kind of pins also. Right? So this one I can call it as pin 0. So basically every wire I can call it as pin. So total I can call it as pin diagram of 74x148. Right? So basically this is a kind of a pin which defines the enable output. This is a kind of a pin which defines the group selection. What is the meaning of all this? I will let you know. Okay, na? The same diagram I have taken for your consideration. Right? Observe, this is a kind of 74x148 diagram, which is meant for the purpose of converting 8 lines into 3 lines. I can call it as it's a kind of encoder, and that too they made it as priority encoder. They made it as priority encoder, so I can call simply as 8 by 3 priority encoder. Now how this truth table will be look like? I am going to have inputs like I0, I1. So with in addition to I0 and I1, what might be the extra things are will be available? I'm going to have enabler, I0, I1, I2, I3, I4, I5, I6 and I7. These are the inputs that we need to pass for the circuit, and you may get the outputs as A, B and C. And C. Similarly, you may get the outputs as group selection, and you are going to get the output as enable out. Enable out, right? Now tell me, when this circuit is going to be off? When it is 0 or when it is 1? When it is 1. Why it is 1? Because we discussed the concept of it is active low. When it is active low, when the input is 1, your circuit is going to be off. At this situation, irrespective of any kind of input, you are going to get always 0. 0 means what? 1 here, right? And what about the group selection? Group selection means GS simply defines if any one of the input is activated. If any one of the input activated, then GS will be 0. Then GS will be 0. Right? What is the purpose of this GS? Like as I am saying that this is a kind of a priority encoder. It has to check which is having the highest priority. Right? So based on that, it has defined as GS. GS as a kind of thing where if any one of the input means those ranging from the I0 to I7, then it is going to make it as 0, otherwise it is going to make it as 1. Is any input is activated? No, then I can make it as 1. Similarly, enable output. So enable output means, so if you would like to realize a large circuit from the small circuits, like if you would like to realize 3 by 8 mux using 1 by 2 mux, then what you have to do? For 1 by 2 mux, every 1 by 2 mux you are going to have one pin as enable output. That enable output pin will be 1. What does the meaning of this one? It is going to depend on other circuits also. 1 by 2 how many required? 4 at the output level. So our final result will be depend on these 4, not on single one. That's why enable in output you are going to be used. So means here am I using any kind of other realization? No. So that's why I made here as enable output as 1. Right? I am simply defining only for 8 by 3 priority encoder. That's why I made as 1. Similarly, if I take the case of enable input as 0, what might be these inputs? This input might be all zeros. Am I right? This input might be all zeros. When these inputs might be 0, you are going to get again the output as all zeros. What about the group selection? 1. Because all inputs are, like any input is activated? No, all are zeros, so I can make it as 1. What about the enable output? Which is also going to be 1. So in our example, the enable output is going to be 1 because we are not going to use it for any kind of further realization. Now, take out the case for another possibility of circuit enabled. So I can take all ones and I mention it as 0. Right? Now what might be the output? What might be the output? See, I have mentioned here MSB beta C. MSB beta C. If I mention MSB beta C, what should be the result? Basically you required 000, but now you require 111. 111. Writing in any order, there is no problem for all ones, right? So what about the group selection? Group selection is 0 and enable output is 1. See, for your understanding, for this particular thing, I am going to write only one case for active high M. So I am defining it as active high. When it is active high, what might be the enable input? 1. All are zeros and this will be 1. These are all zeros. This will be 1. This will be, sorry, this also will be 0. This will be 1. This will be 1 and this will be 1. This is for active high. But what we are trying to write? We are trying to write it for active low. So that's why I mentioned like this. Right? Now what about the next level? Circuit is enabled and all the ones are possible. This is 1 1 0 1. Now what about the output? Output is 0 0 1 actually. So you need to get 1 1 0. That 1 1 0 again you have to write in the form of 0 1 1. Okay, 0 1 1. So here the group selection will be 0 and it will be 1. Right? So can I write directly 0 followed by all ones followed by 1 0 1 1 1. Right? And now what might be the output here? So this is like 0, right? 0 1 0. Can I write directly? Okay, 0 1 0, it will be 0 and it will be 1. Right? But the point you have to understand one thing. As I am saying that this is a kind of a priority encoder, pinout encoder. If I am going to get 0, it is okay. What about this particular case? It should be don't care, and here also it should be don't care. It should be don't care, right? Fine. So next one, 0, 111, 0, 4 ones. This will be 0. This will be don't cares. And what about the value? This will be 4, right? This will be 4. 4 or 3? 4. When it is 4, what might be the value? 100. For that, you are going to get 011. 011 will be converted again. Whatever you are saying, I am simply writing. 110, which will be 0 and it will be 1. Is it correct or wrong? Okay. So if you want to avoid the confusion, I am just remodifying this structure so that again it will be easy. I will make it as I7, I6, I4, I3, I2, I1 and I0, and I will write as now. It is okay. So can you write now? So assume I am trying to write again for these 3. Try to observe what is the value of this one. So I hope you understood for this one, right? When first input line I0 is activated, you are going to get all zeros, that will be all ones, right? Similarly, when I1 is activated, you are going to get 001. 001 I can represent as 110, right? Similarly, when I2 is activated, you are going to get 010. 010 I can be written as 101. Very good. When I3 is activated, you are going to get 011. That will be written as 100. Right? Similarly, here the case is 0 followed by 110. All are don't cares, and you are going to get 100. 100 means 011. This will be 0 and this will be 1. 0 1 1 0 don't care, don't cares, and this will be so 0 1 0. What meant is the 1? 0 0 1 0 and 1 0 0 don't cares, and you are going to get all the don't cares, and you are going to get the value all zeros, right? So this is the way your circuit is going to be working, right? Whatever circuit they have given, the circuit is going to work in this particular position. Means when enable input value is 0, your circuit is going to be activated, and for the respective cases it is going to produce the respective outputs like this, right? If I will show in terms of its circuit diagram, your circuit diagram will look like this, right? If you are able to solve it in some order, you are going to get this circuit diagram. So this is for IC74X148 circuit diagram, means internally how the circuit is implemented, right? If you are able to observe, it will look like as it is, but internally the implementation will be like this, right? So for that, how internally to work, that is what we have drawn some kind of truth table. We can call this as IC74X148 truth table, right? I hope you understood clearly, right? So means if you would like to get the achieve the functionality of 8x3 encoder, how you have to like connect your wires in the breadboard. I hope you know the meaning of breadboard, right? In breadboard, you have to connect the wires in such a way that it has to follow always this particular order. If you are not going to follow this particular order, you are going to get wrong outputs, right? Fine. Okay, so we'll stop here and we'll continue the next.